Hello everyone. Today we are going to start our session for the ninth time during this coursework. So my name is Sumit Kumar. We are taking the class of Geotechnical Engineering 2. This is the NPTEL course series in which in the ninth session today we are meeting. So during this session we are going to discuss some of the problems, specifically numerical problems. Other than that, we are going to discuss the C file one. Before starting, I will add some point like some instructions. The instructions are that this video is getting recorded and this will be shared with you in the meantime after the class get over. If we, and those of you who are not attending this session during the live may come over here and can attend on a YouTube and get benefited. And if any query there, you can comment over there as well. Apart from that, you can communicate with me during the next session regarding your doubts. I will happy to respond to that. And the presentation file which I am showing during the course this time as well will be shared with you through by the NPTEL team. The links for the Google Drive is already shared with you, and the files will be uploaded over there only. Okay. Apart from that, and those persons who are attending this in YouTube, please go across all those questions and solve those problems. That will be most beneficial for you. And during this today's session, I am going to discuss specifically the points like in the earth pressure theory. Specifically in the earth pressure theory, we are going to take problems because during the last session also we have taken many problems, but some problems are left there due to the time constant. So we will complete those as well in during this session. Apart from that, the seed pile walls, basically the theoretical consideration will be the main consideration today, which we are going to discuss. Okay. Some additional point I want to mention over here, like if in any circumstances the electricity get shut down or maybe due to some network errors, if my call get disconnected, please be remain in a meeting. I will rejoin in a while and continue the session. The session will be going to take place up to 2 hours from 3 to 5, and during these sessions, whatever your doubts, whatever your confusion regarding the subjects, you can ask over here. Apart from that, and some concepts and some problems will be discussed by me. Okay. So before starting further, I will again recap the some of the points which we have discussed during these sessions during the last 8 weeks. So first of all, we have understood the what do we mean by the shear strength of soil. After understanding the meaning of shear strength, we have discussed the concepts to find the shear strength, how we can find the shear strength. And the finding shear strength is one fact. Apart from that, the different type of test which we are performing. We also understood the different type of test like the box test, direct shear, that is the direct shear test, triaxial test, main shear test, and many more tests we have gone across. But these are the three tests which we have discussed in detail. From the understanding of those tests, we also understood the significance. Significance means importance. What is the importance of doing this test? What is the importance of the shear strength in the geotechnical engineering? Because anything we are doing must have some importance, otherwise there is no meaning of life. Specifically, if we are talking about any scenario, anything which we are doing, it must have some significance in our life. So the significance of the shear strength we have discussed. We have understood the Mohr circle and basically the graphical and analytical method to find the okay, okay, give me a minute. Okay, sorry for the interruption. I think so now audio and video will be clear. Due to some technical issue, some noise came during my meeting. That's why I have abstracted for a while. Okay, no problem. So moving further, we are discussing about what we have done up to now during our last eight sessions. So today we are going to add on the points which we haven't discussed, which we discussed specifically during the shear strength of soil. So basically, we are applying. We have done the application part, what we have read during the geotechnical engineering one course during this coursework. So, what are the additions? What are the understandings one can gather from the study will be one of the most important parameters. After the understanding the shear strength, we have understood how shear strength is important, specifically during before any construction. We are talking about how much the strength of soil, because if we doesn't know the strength of soil, it doesn't matter that in any way we could construct any structure over there. And when we are talking about structure, it is not always building, it may be infrastructure projects like road and railways. So the strength is the most important aspect at many places. So we have understood the shear strength. We are talking about the Mohr column. Mohr circle criteria. So the Mohr circle we have understood by finding the value of stress in the two vertical direction. We can find the normal and shear stress at a specific angle. We have understood. We have taken many problem as well on those concepts during our first two lectures. Recently, in the last three classes, we have discussed the earth pressure theory. In earth pressure theory, we have understood what do you mean by the earth pressure at rest, what is mean by active earth pressure and passive earth pressure. We have also solved many problems specifically during the last and last to last class based on the earth pressure theory. We have also tried to solve some problem on the seed pile wall as well, but there is a discussion remaining on the seed pile. So today I will take its theoretical consideration. I will also take a design consideration of to a while, but I'm not going into detail for today. In today's session, we have taken the theoretical consideration which we are taking into account for the seed pile wall. There is a little design consideration for the cohesive soil will be discussed at the end of the class, or maybe during the if time permits, it will be discussed today. Otherwise, we can extend during the next class. It doesn't never be a problem for me. Okay. So going ahead, first of all, I want to give you few quick recap of the last session, and afterward we will start. Okay. So again, I am going to share my presentation. I will give a quick review from the last session, and afterward we will start with a fresh content which will be prepared by me for the today's session. Okay, so I'm sharing my presentation. I think so. My presentation will be visible to everyone. Okay, yeah, it is visible. Okay, so I think so. Presentation will be clearly visible. Now I will go ahead with and those considerations which we have discussed, specifically the theoretical parts we are going to take on over here, because it is needed for the today's class as well. Afterward, moving on, we will go into deep into the account of what is actually understood by the seed pile wall, and then we will take several problems. Today, I have make some questions, very easy problems, very easy questions that will help you to understand the fact of what we understood with the help by the means of the seed pile wall and how it will be helpful in many ways. Okay. So earth pressure theory, we have discussed the earth pressure theory. We know the Rankine earth pressure theory, there Coulomb earth pressure theory, there the Coulomb wedge failure criteria. We have understood the assumptions which came across with the Rankine earth pressure theory. During the earth pressure theory, we have understood the earth pressure at rest. We also came across the knowledge of the earth pressure in active state and earth pressure in passive state. So the different consideration which we came across over across the time period will be discussed. So we specifically know. that the entire earth pressure theory has been given for the cohesionless. So in that case, we are calculating the earth pressure for the cohesionless soil. So the earth pressure constant is nothing but the ratio of sigma horizontal by sigma vertical. So ultimately, the earth pressure which is acting in the horizontal direction will be given as sigma h equal to k into sigma p, and that's not a big deal, and that is a very easy things to understand by anyone. So where is the problem? The problem arises when the scientists came across the fact that how to calculate the value of earth pressure when the soil is a cohesive, because it is not always the case that we find the soil always to be cohesionless. So for those cases, the another scientist came in and take the responsibility to frame the solution for that given problem. So in the solution, he suggested that we are going to take the cohesion in such a way that as we know in the last to last class as well as last class we have discussed this consideration, like the earth when the wall move away from the backfill, it is the active state, and when wall move toward the backfill, it is a passive state. So when we are taking the consideration of active state, the cohesion ultimately result in the reduction in the earth pressure in the horizontal direction, and vice versa takes place for the passive earth pressure in for a cohesive soil. So our ultimate relation at any depth z become k into sigma v minus 2c root k for active earth pressure, while for the passive earth pressure kp into sigma v plus 2c root k. Now understand one simple thing. And what is the simple thing? That simple things is that when the wall move toward the backfield, it result in the addition of stresses in that direction as compared to what taking place when it's move away from the backfield. When it move away from the backfield, it reduces the stresses, it reduces the pressure on the wall. It result in that consistency. So that things is very easy, and I don't think it need to be repeated again and again, but it is a basic concept. So it's my opinion to discuss it again for the better understanding of the subjects and the things which we are going to discuss over here. Okay, so these things are very simple. Sigma A equal to k into sigma z minus 2c root k. Now your question is what is sigma z? Sigma z is nothing but sigma z is the effective stress at depth z, and effective stress concepts you have read during the geotechnical engineering one, that is nothing but the gamma into depth of the soil. And when we are talking about the effective stress, so the what is the water, where is the water is also one of become one of the most important aspects, because it will result in the, it will create differences, it will result in some differences in the soil. So we need to deal with that. Suppose uh, we are calculating the suppose we are calculating the earth pressure at depth 6 meter from the ground floor. So, and the water table lie at 4 meter. So, in that case, when we calculate the earth pressure coefficient at 6 meter, suppose it will be 1 by 3. So, the sigma z value will be multiplied in the effective term over here. So, we take gamma, we calculate sigma z as suppose the value of unit weight above the backfill, that is the gamma bulk is 18, and above the water table is 18, and below the water table, that is gamma saturated, will be 21. So how we calculate? We calculate k into 18 into 4, because up to 4 meter there is no water. Below the 4 meter the water table is there. So the below the 4 meter the water, the soil is completely saturated. Okay. So we calculate in which manner? We take k into 80, k will be 1 by 3. So 1 by 3 multiplied by 18 into 4 plus 21 minus 9.81 into 2, and afterwards, because the q, the water pressure will be not added in this, water pressure is added separately without multiplication of the earth pressure coefficient. And why this is taking place? because that pressure due to the water will be acting from all directions, so the earth pressure coefficient multiplications for those stresses will underestimate our result, will of no use specifically if we are saying, because that will not considering any effect on that portion of soil when we are calculating either active or passive earth pressure. So I think this point will be very well discussed by Sir as well. So I don't think it need to be elaborated. If anyone have doubt, they can text me in the message box. I will explain by writing it on a whiteboard as well. But up to this, I think that thing will be clear, because that will also be discussed during the last session. If any one of you who doesn't attend it may go from the YouTube presentation, YouTube video, you will get the idea about that in a very good manner. Okay. Now the earth pressure coefficient, what I am talking about, that is 1 minus sin phi by 1 plus sin phi, and similarly for the passive 1 plus sin phi by 1 minus sin phi, that is not a big deal, that is very well understood by you. So the earth, the QS surcharge which I am talking about, that will be mentioned over here. So I have already discussed. Similarly for the passive earth pressure, the Kp into sigma z plus 2c root Kp, and Kp is 1 plus sin phi by 1 minus sin phi, and that will be equal to tan square 45 plus phi by 2. When we are talking about K, that is tan square 45 minus phi by 2, but that is not only the case, it will also be written as 1 minus sin phi by 1 plus sin phi and equal to cot square 45 plus phi by 2. So it will be sole responsibility of the uh, persons who are solving this problem, because this is only a trigonometric problem. When you solve trigonometrically 1 plus sin phi by 1 minus sin phi, ultimately you get the result as tan square 45 plus phi by 2, and converse is also true in this case. Okay. Okay. So we also understood the inclined backfill. We have also solved a very good problem on the inclined backfill, where the backfill inclination beta has been given. So we have calculated the earth pressure coefficient over there. We have to calculate the passive earth pressure coefficient, and that question will be taken during the last session. And in that problem, we understood that how the backfill slope will be mentioned and how we are able to calculate our result in a true sense. Okay. Now, we have taken the Coulomb theory in the previous class. From this last class as well, we have taken the assumptions of the runtime theory, Coulomb theory, and we have developed the interrelations, that how we are able to calculate those values. So up to that only in the revision sessions from the last class, I want to take. I will read this. In the case of the okay, so that is not of very much importance during this session. So now I will go with the new content. Type of the retaining wall, we have discussed the gravity, cantilever, and diaphragm wall. Okay. So up to this, I want to get a division from the last class. Now I will start with a new content, which will be more or less very helpful for you from the today's session. Okay. So give me a minute before I will share that content with you. Okay, I think so. My presentation will be visible for everyone. If anyone is not able to see, can may write in the chat box or can comment as well. The There is no problem with that. Okay. Yes, the presentation is clearly visible. Okay, so we are going with the Geotechnical Engineering 2. We are very well known. This is the course on the NPTEL Geotechnical Engineering 2. The Professor DN Singh sir will be taking this class. Okay. So now, first of all, we start with the small problem. Afterward, we will solve some numerical problem in up to the first half. After that, we will move to the seed pile wall. Over there, we will discuss the theoretical consideration, its advantage, disadvantages, its usage, the problem associated with seed pile wall, what are the solutions one can suggest for the seed pile wall. Afterward, we will take the multiple choice questions on the seed pile walls, and in the end, we will also take the design consideration for the seed pile wall up to an extent, if the time permits for today. Otherwise, it will be moved for the next session. Okay, I think so. No problem up to this. Okay, so the first question over here, what is the main function of the retaining wall? So any one of you say that the retaining wall is only constructed to retain the soil behind it. Other function could also be there. So before moving to that, we will read the statement and the options, and afterward we will draw the conclusion. So whether the retaining wall support the vertical slope? Yes. It will prevent the soil erosion, obviously, because the retaining wall will be created. It will not allow the soil to move from there. So it will also provide erosion resistance up to extent. Whether it will provide drainage. So the answer is yes for this case as well. So what will be going to be our answer? Our answer will be going to the option number D. I think so. That thing is very much clear for anyone. Yes. See. So all the options given above is true. Now, see the explanation also mentioned over here. The explanation is that the retaining wall are used to support the vertical slopes, prevent soil erosion, and also provide the drainage. It is also used to create the trackers levels out even ground, and some other considerations will also be there. They are also used to create the trenches level out on even ground and create the raised beds for gradings. So these things are we are taking there. Up to this, I think so. No problem during these questions. So we will move ahead. The next question is, which of the following is the most common type of retaining wall? You understand in the last slide from the division slides, you have seen the gravity retaining wall, cantilever retaining wall, buttress retaining wall, seat pile retaining wall. Today we are going for the seat pile wall in detail. So the question over here that which of the following is the most common type of retaining wall? When we say the gravity retaining wall, cantilever retaining wall, and buttress retaining wall, so the question is there, which are the most common types? So the answer for this problem is option number A, that is the gravity retaining wall. And why the gravity retaining wall? So no doubt the gravity retaining wall is the most economic as well in its aspects. And apart from that, the gravity wall, gravity type retaining wall is widely used because it will be very easy to install as well, and they are simple to design. As I have said earlier, the gravity retaining wall doesn't provide any hindrance during its design. Very easy designs, and most importantly, its construction is also more or less very provide a ease in its construction. And they are made of heavy materials. When we are talking about the heavy materials, what do you mean by that? Such as the concrete or stones, because the gravity wall doesn't use external material. So it is used material over from the site only, such as concrete or stones, and also rely on its own weight. So it will be most economical also, but there is some limitation as well when we talk about the gravity retaining wall in detail. That is, its construction height is limited. It is not the fact that we can construct up to any height. So that is one of the most concerned effects which one can look into that. But more or less, the gravity retaining wall act as the most commonly typed retaining wall across the globe to support the soil. Because why we are talking about retaining wall in such detail? Because the retaining wall is one which resists the soil movement behind it and ultimately result when we are talking about the backfill is the soil and it is resisted, it is retained. When the wall is moved away from the backfill or when the wall is moved toward the backfill, the wall is nothing but that retaining wall only which we are talking about from the initial time only. Okay. Okay, so read the next question and try to answer. In the meanwhile, I will take some water. Okay, so Have you read the problem? Okay, no problem. I will read. So the question is here: what is the main function of retaining wall? Again, the four same solutions problem will be there. I think so due to some technical error. The same question has been repeated over here. So to support the slope, vertical slope to prevent the soil erosion and to provide the drainage. All the options given over here is the correct option. This question is already there during two slide earlier, but due to some reasons it came again. Again, which of the following is the most common type of retaining wall? Gravity retaining wall. It is only for revision. This has been repeated in different manner. Okay. Now the next question. Which of the following material is commonly used to build the retaining wall? Or when we are talking about commonly, whether all the material could be used to construct the retaining wall? That is also one of the question. So, what do you think? Whether the concrete, stone, wood, everything will be feasible for the construction of retaining wall? If we are talking about that fact, then the another question came in our mind: whether the retaining wall which we are constructing is for what purpose? Are we want to resist the soil from moving from that points, prevent it from erosion, or we are storing the water behind that? Because the pressure which is acting on retaining wall due to soil and due to the water pressure will be completely different. Those two things doesn't came hand in hand. So that will be well understood by you. I think so. That is not a concern. I think from anyone's side. So, what do you think? What is the solution of this question? So, the option number D is the correct answer because the concrete stood everything could be used to construct the retaining wall, to build a retaining wall. But the one things also keep into mind that the retaining wall is constructed for what purpose because if the purpose is not defined, some places the strength which one needed to be required for the construction of the retaining wall at certain workspace might be not provided by the wood but can be provided by concrete. So those aspects you need to be take care of. Okay, no problem. Moving ahead, when we go for the next question, the question raised over here like the what is the purpose of the weave hole in a retaining wall? So the question is very new for you, I think so, because this is not discussed during this session. But I have only put some of the problems like this in the presentation only to give some of the fact which maybe you are not aware of, but after understanding you will understand those points well and good. Okay, so the question is, what is the purpose of weak force in a retaining wall? Whether to allow the drainage, to relieve the hydrostatic pressure, to prevent the soil erosion, or all of the above. Even you see, to allow the drainage and to relieve the hydrostatic pressure came hand in hand, and to prevent the soil erosion, whether we provide a weak force. So the solution for this problem is yes, all the options which has been provided over here is true. So I actually try to put the options which are correct. Why? Because this will give you the broader aspects. If the only one option is correct, the rest three options you never understand. But now when you go across with this question, afterward you will have confidence that these are the true solutions. So the other solutions you might be think of like that is not correct. So you can answer the problem if it is same problem is asked in a different manner at specific places. Okay, I think so. The things will be understood by all of you in a very well manner. Now the question is, what is the purpose of geogrid behind a retaining wall? You have seen in a recent past in a retaining wall, behind the retaining wall, the geogrids are provided. Why? Whether it act as a filter or it differentiate the two layer? Because we have seen its application at several places from the past few years, the geotextiles, geogrids. are widely used all across at some places it might serve as a reinforcement for the backfill soil. So what are the options? First of all we see, then we will answer the question. And it also act as a filter. It sometimes provide the efficient drainage facility. So one should be very much aware about the fact of the application of the geogrid behind the retaining wall. Okay, so our options are to reinforce the backfill soil, to prevent the soil erosion, to improve the drainage. Now any one of you who are understanding the facts, what I want to convey from the last two sessions as well while studying these things will easily answer. The correct answer for this question is option number D. Okay, because the main purpose it will serve will is it reinforce the backfill and reinforcement of backfill in a at any place in a retaining wall is done by the geo grid only. It is not like that. Geo grid is not made up of steel or anything like. It acts as an enforcement because it confines the soil over there. So that things will be clear. You need to understand up to this only because the geogrid and geotextiles is become itself another topic that will take might be 7 to 8 hours to discuss if I am going very fast also. So I am not going into that. You must read about those things in a ground improvement techniques course or most efficiently in a ground improvement technique course. You came across those topics like the geotextiles and geometry. But up to now, you will understand these 3 points, and that will be enough for the advanced foundation engineering or geotechnical engineering, to whatever we say. Okay. Now, what is the next question? Is what is the most common cause of retaining wall failure? Failure also takes place. It doesn't like we have constructed any structure, it doesn't fail anytime. But it should be the duty of we engineers to design the structure in the most efficient way because the failure of any structure will result in a big could be result in a big disaster and that cannot be accepted in any way. So the design should be most appropriate, but afterward as well this failure takes place. So what are the reasons behind the failure of a retaining wall? So the four options are provided here. Improper drainage, exactly. If the drainage is improper, it will result in the increase in the pressure. If the improper drainage is there, so the effective stress result in reduction. If effective stress get reduced, the strength ultimately result in ultimately go downwards. So that will not be good in any way. So it may lead to the failure. Second option is inadequate foundation depth. Yeah, foundation depth is equally important, and overloading is the third consideration. So I think so up to now you exactly understood the option D will be going to be our correct answer in this case as well. So basically you could take this as a question. You may also take this as a concept because in all the problem, in most of the problem which we have came across from early, the all the above is the correct answer. But my concern to provide the 3 point in one question, so you will get a clear idea of the fact that what we are studying, whether it will be when the application part is asked, specifically 3 questions could be framed from this question only. But in one question, all the 3 points are provided to save the time as well as to give the proper understanding to you. So, what you understood from this problem? The cause of failure could be the improper drainage, inadequate foundation depth, and the overloading. Okay, I think so. Up to this, there will be no problems with anyone. We will move ahead. When we move ahead, the new question came in front of us. How can retaining wall failure can be prevented? We have understood that the failure takes place due to the reason. But at any places, when the problem came into picture, one must have to think for the solution because every problem has one or more solution. So solution is the one aspect. So what could be the solution? First of all, we read the options, then we provide the solution. So the options are the proper design and engineering. So this is the basic aspect. This will be completely true. Use of the high quality material. Yeah, high quality material also reduce the chances of failure. But that not also always the case. So we can accept this point as well. Now the proper installation, specifically when we talk about the quality control, this will come with the quality control. If we have designed, if we have used the good material, but the implementation of those things at the site over the retaining wall is constructed is not implemented in a better manner, so it is going to be next to impossible for any designer to give the design in such a way that when the application part has not implemented in good manner will give the good result. So these things will be we need to be very clear in everyone mind. So the option number D is the correct answer. Now this is the questions. Okay, this is the question which asking what is the difference between the gravity retaining wall and the cantilever retaining wall. We already discussed in the types of retaining wall in starting of this session, as well as during the last session or the revision session. You have seen the gravity retaining wall, cantilever retaining wall, buffer retaining wall, and different type of retaining wall we have came across. So the question over here, the difference between the gravity retaining wall and a cantilever retaining wall. So the first option you must understand, the first option is saying a gravity retaining wall releases relies on its own weight to resist the lateral pressure, while a cantilever retaining wall relies on its bending strength, and this is completely true. I think so that is not a problem to understood by any one of you, because in the gravity wall we have already understood, we already discussed that it rely on a self weight to provide the strength to the soil. Okay. Now the second option is the gravity retaining wall, typically used for the lower heights, while a cantilever retaining wall and it typically used for the higher heights. I already said there is a limitation with the gravity retaining wall with its height. Okay. Now the third option is a gravity retaining wall is typically made up of concrete or stone. Specifically, we have read also this during the this session added this day. So could be made of concrete or stone. Whether the concrete retaining wall is typically made of the reinforced concrete, obviously because the cantilever retaining wall could not extend any places if that is not provided. So option number D is going to be our correct answer. Okay, I think so. The things are very much clear. Now the next problem is in front of us. Next problem is about what is the difference between a buttress retaining wall and seat pile retaining wall. During the starting session, you have seen all the retaining walls images, and now we are coming across its application with its name, so one can understand the fact about this. Okay. So the question is the what is the difference between a buttress retaining wall and seat pile wall retaining wall? When we came across the last problem, no, we have read the difference between the gravity retaining wall and cantilever retaining wall. This could be one problem. All the options are correct, so the three solutions are provided. The three differences are stated over here. Similarly, with every problem from earlier as well, the solution are stated. All the above options are mostly correct. So the three solutions are provided. Basically, three questions could be framed from the same aspects, but the only one question is framed to give you the more knowledge in less time. Okay. So over here, so what is the difference between the buttress retaining wall and a seat pile retaining wall? So the option A is a buttress retaining wall has a vertical buttress that support the wall, while a seat pile retaining wall is made of interlocked metal sheets. Okay, exactly, it is true. A buttress retaining wall is typically used for the higher heights, and a seat pile retaining wall is typically used for the lower heights. Okay. Now, A buttress retaining wall is typically made up of concrete or stone, while a sheet pile retaining wall is typically made up of metals. So the option number D is going to be our correct answer. So over here as well you find the three differences between the buttress retaining wall and the steel pile retaining wall. So you need to be understand this fact. You have to preserve this question and prepare this question as a solution of the three problems. The same problem could be asked from the three directions and it will ultimately state in the same result. So these things you need to be understood. Okay. Okay. So we are going little slow. We need to boost up our speed in order to complete the content which has been there for the today's session. Okay, that will not be a big problem. I will go in a better way. So you will the understanding is more important than completing the whatever time it will require to understand the session is most important fact in my thinking process. Okay. So you have stated the solution for this problem. Now, so prepare these questions. You can write it in this notes as well as a different. Okay. Now the question are what are the factors that should be considered when designing a retaining wall? Okay, so the height of the wall is a factor. Obviously, the type of the soil, surcharge load, or all the above are the options for this. So the height of wall is one of the most important consideration while designing a retaining wall. Second, the type of soil is also important, whether the soil is the cohesive or cohesionless, whether the soil has plasticity property. So those facts need to be reviewed. Okay. Now the third thing is the surcharge load. The surcharge load is the load which has been applied over there during the construction or before the construction, or what will be the load, surcharge load, the superstructure load which will be coming over there throughout the region. So all those factors become the most important consideration during the design of a retaining wall. Okay. So up to this, there will be no problem for anyone. Okay, so we move for our next problem. I think so understanding you will be very much clear up to this. So next problem, the question is there. What is the steps involved in construction of retaining wall? So the steps are like we have to prepare the site, we have to install the foundation, we have to build a wall, backfill and should be compacted. When the backfill is compacted, it will exert a pressure. So those facts are there. So all the options, all the above will be going to be our correct answer for this question. Yes, exactly. Now we come for the next question. The next question is what are the types of maintenance that should be performed on a retaining wall? Okay. So the with this could be asked in a different manner as well, but the correct what should be going to be the correct answer? Inspecting the wall for the cracks and the other drainage damage. Repair any damage that is found, cleaning and removing debris from the wall, all the above. So what are the type of maintenance? Inspecting the wall for the cracks and the other damage? I think so. It will be going to be true. The repairing any damage that is found, obviously, that is one of the most important aspects. After cleaning and removing debris from the wall is also one of the important aspects for while we are going for the maintenance of the retaining wall at any workplace. Okay. Now, what are the benefits of retaining wall? When we talk about retaining wall, some other types of things are also there already there. It is not like that. This is the first thing one came across, but it is already there. So, what are the benefits? So, there are several benefits like they support the vertical slope, obviously. They can prevent the soil erosion. This has been seen during the first problem for today only. They can provide drainage, obviously. So the option number D is correct answer, and this is also for the revision purpose from the last session. Okay. So we have end up with the questions, the simple theoretical question. Now we will go with some of the numerical problems. Very simple, small numerical problems we came across, and afterward, I think hopefully we could understood, we could read the seed pile wall up to extent during this today's session only. Okay. Okay, so the question is here: a retaining wall is 3 meter high and retrains soil with a unit weight of 19 kilonewton per meter. And the angle of internal friction has been given as 30 degrees. So, what will be the active earth pressure on the wall? In kilometer per meter square, it will be going to come. So, the phi is 30 degree already given. The value of K is going to be 1 by 3. And the question has been asking the active earth pressure of the wall. So the solution is going to be the active earth pressure on the wall is calculated using the Rankine equation, and PA is going to be 1 by 2 into gamma into h square into k, which we usually use to say 1 by 2 into k into gamma h square. So the value of k is going to be 1 minus sin phi by 1 plus sin phi, and the PA is going to be the active earth pressure in kilometer per meter square. Similarly, going to be in kilonewton per meter cube, where the height of the wall is going to be h meter, and the active earth pressure coefficient is said to be K. That is the coefficient of active earth pressure. Now, the active earth pressure coefficient is calculated as it follows. It has been already mentioned: 1 minus sin phi 1 plus sin phi, where phi is the angle of internal friction. Therefore, the active earth pressure has been calculated, and ultimately we are going to find the PA value as 1 by 2 into K into gamma into h square, and the value, indeed value, has been found. I think so. There will be no problem from here up to this. So in the solution we have solved the problem and reached to the conclusion like the active earth pressure is 30.343 kilonewton per meter square. Okay. Now the second part of the problem, and that problem is asking: a seed pile wall is 4 meter high and retains the soil with a unit weight of 20 kilonewton per meter cube, and the angle of internal friction is 35 degree. The passive earth pressure on the wall. So the passive earth pressure on the wall is supported using the Rankine equation. So the PP is giving as 1 by 2 into gamma into h square into Kp, and the pressure earth, and the passive earth pressure coefficient is as 1 plus sin phi by 1 minus sin phi, where phi is the angle of internal friction of the soil, and therefore the passive earth pressure on the wall is PP equal to 1 by 2 into 20 into 4 square into 1 plus 1 by sin 35 by 1 minus sin 35 as 72.1 kilonewton per meter square of pressure at that. Okay. I think so well and good. I think so there will be no confusion up to this in anyone mind. I don't think so. So the next problem is: a retaining wall or is of 2 meter high and retains the soil with a unit weight like this, and the angle of internal friction is going to be this. So what is the minimum depth of the wall of the find to resist the overturning? So the solution of this problem is going to be dF equal to PA into H by W into F, where the PA is the active earth pressure and W is the weight of that place, and F of the wall, and F is the factor of safety. During this calculation, we are able to calculate the dF. So, the assuming the unit weight at 20, minimum depth has been found at 30.43 into 2 by 20 into 2, and we reach to the value of 0.69 meter in this case. Okay. Now, the next question is about a sheet pile wall with a height of 3 meter high and retains the soil with an unit weight of 21 kilometer per meter cube and an angle of internal friction at 30 degree. So this will look like the same problem as we have solved earlier. So you have to find the um, okay, no problem. So in this problem, we are able to find the TE value. I think so. Up to this, there will be no confusion in your mind. Okay, so this problem is already asked. Question number three. This has been repeated over here. What is the which of the following material could be used to build the retaining wall? So the option number D is the correct answer. That is the concrete, stone, wood, and so all the above will be going to be the correct answer. Okay, now we will solve some problems, the small problems before moving ahead. So before that, before starting that, we will take a small break of 5 minutes. After 5 minutes, we will start again our session because up to this, up to that, please wait. Welcome, welcome back. I think so. My audio and video will be clear. Okay, I think so. It is clear. There is no problem from my side. So we will move ahead in our solution, and we will see whether. Okay. So first of all, we start with the question, the small problems. Some of the problems are there which has been remained during the last session as well. So first of all, we will take the solution for the problem, and then we will go for the understanding of the seed file wall up to extent. And up to that, the today's session is going to end, and the remaining thing will be covered on the next session. So after this today's session, there will be three more sessions as well remaining, or it might be if needed one more session I will take as per the requirement. But as of my knowledge, there are only three more sessions has been remaining from here. Okay. So first of all, we will start with this problem. We have discussed this type of problem last time as well. So the surcharge loading required to be placed on the horizontal backfill for a smooth retaining was so to completely eliminate the tensile crackage. So we already know if we want to eliminate the tensile crack ultimately, we have to keep a surcharge. So I think so. This point I will explain. I will explain over here. Uh, don't worry. I will explain that things with the question with the for the solution of this problem. Okay, so give me a minute. I will take a pen and I will write. So the you have understand this fact like k gamma z minus 2c root k is there. If you want to completely eliminate the surcharge, so k gamma z minus 2c root k at z equal to 0 should be 0. So the surcharge should be like this. First of all, we write k k into gamma z, that is sigma v. Okay, now I think so. There is no problem in this understanding. K gamma z plus q, because the surcharge will be multiplied with the earth pressure coefficient that has been discussed in the starting of today class as well. Okay, the k gamma z plus q minus 2c root k minus 2c root k. Okay, so this should be equal to 0. So solving this, what we get, we find this will be going to be 0. Okay, because at z equal to 0, this is going to be 0. So q will be going to be 2c by root k. Q equal to 2c by root k. So option number D is going to be our answer. Q is going to be 2c by 2c by root k. I think so. There will be no confusion in doubt up to this. So the solution for this problem is going to be option number D. Okay, everything is crystal clear. It has been explained with the written solution. So there will be no confusion in anyone's mind. If any doubt from anyone, they can ask. Okay. So this has been explained over here as well with the schematic diagram. So you can go across that as well, but what I have explained will be give far better understanding than that. Okay, so we'll move to the next problem because we are running little bit out of time as well. So the next question is a 6 meter high, a 6 meter high retaining wall having a smooth vertical backface retain a layered horizontal backfill. Top 3 meter thick layer of backfill is sand having the angle of internal friction phi equal to 30 degree, while the bottom 3 meter thick clay layer with a cohesion C equal to 20 kilopascal means 20 kilonewton per meter square. So the assume the unit weight of both sand and clay is 18 kilonewton per meter cube. The total active earth pressure on the wall. So we have to first of all draw the earth pressure diagram. Afterward, we will find the area of that earth pressure diagram will be the solution of our answer. Okay. So again, I will draw that for you over here. So you will get the better understanding. That's why I will take this opportunity to draw with my hand. Otherwise, the solution is already there. But to give the better understanding of the fact, I want to explain these things with exact solution, so we will be get better idea. Or I can go with the solution as well. Okay, I will go with the solution only because it will take a huge time. So that will be better. I will show the solution only. Okay, so the question has been asking that a 6 meter high retaining wall is there. 6 meter high retaining wall is there having a smooth vertical backfill. Face retain a layered horizontal backfill. Top 3 meter layered backfill is having sand. Top 3 meter has been sand and phi is equal to 30 degree. While the bottom 3 meter layer will with clay. Okay, with a cohesion has also mentioned as C equal to 20. Assume unit weight as 18 kilonewton per meter cube. So total active earth pressure per unit length we have to find. So in this question you see first of all the earth pressure diagram has been drawn. So and you must understand the earth pressure diagram has been drawn over here and then its area has been calculated. So I will explain these things first of all to you. Over here, for the first 3 meter, the sand is there and the value of phi is 30 degree and gamma is 18 kilonewton per meter square and C is 0. So the value of K over here, the value of K is 1 by 3. Okay, for this section, K is 1 by 3. Okay. So it has been also calculated K1 is 1 by 3, K2 is 1 by 1. Okay, over here you will see. And so the value of PA is K gamma Z. So this value has been came as 18 kilonewton per meter square. So this 18 has been mentioned over here. After that, for PB, K2 into gamma Z minus 2C root K2 has been calculated as 14. So this value has been found 14. Okay, and after that PC has been calculated and that has been found as 68 kilonewton per meter square. Afterward, the area of the earth pressure diagram has been found, so we will reach at the answer. This is the area of earth pressure diagram. I will write it here so you will understand later as well. You came across this PDF, area of earth pressure diagram. Okay, na? So you have to understand only this thing. Um you have to understand only this thing that if it is found said to find in kilometer per meter total earth pressure or anything like that, so this means we have to calculate the area of the earth pressure diagram which we have already drawn, which we have also understood how to draw it during the last session. We have taken many question on this. Okay. Okay. Now, see, a question saying a vertical cut has to be made in a soil of a mass having. co- Okay, in the previous problem, one thing has not been cleared. The answer for this problem is 150. So the solution has should be need to be mentioned. So this option is correct option. Okay. Now, the question over here is asking a vertical cut is to be made in a soil mass having a cohesion C equal to angle of internal friction as phi and unit weight gamma. Consider K and Kp as a coefficient of active and passive earth pressure respectively, the maximum depth of unsupported excavation. So when this question has been asked, this has been already understood by you that for the maximum depth of unsupported excavation, the depth should be 4c by gamma root k. And how we come to know? Basically, we know k gamma z minus 2c root k. Up to that, if we at that point if we found the stress is zero, but up to 4c, basically zc equal to 2c by gamma root k, and 2 up to 2 zc we could provide, we need not to provide any support like scaffolding to support the soil, so that soil can remain stand without any support up to depth of 4c by gamma root k. So the solution of this problem is going to be option number D. Okay, see, option number D is already mentioned over here. So this thing will be very much clear for everyone. Now see this problem. This is one of the very good problem. Basically, in this problem, the first of all we do read the question, and I will explain what is the thing which people commit mistake while solving this problem. So the question over here: the soil profile at a site consists of 5 meter thick sand layer underlain by a C5 soil as shown in a figure. Now, the water table is found at 1 meter below the ground level, which also mentioned in the diagram. Now, the entire soil mass is retained by a concrete retaining wall and is in active state. The back of the wall is smooth and a vertical. The total active earth pressure expressed in kilonewton per meter square at point A. So for solving this problem, we have to find the K value in a soil 3. So over there, phi is not mentioned, so phi is 0 because the soil is clayey. So K become 1. Now 1 into the gamma z. Basically, when you say gamma z, so you multiply that with 16.5 into 1 plus 19 minus 9.81 into 4 plus 18.5 minus 9.81 into 3. Uh, so that is going to k gamma z minus 2c root k. So k is 1, so minus 50. And sorry, k is not 1, 5 is mentioned 24. So you have to find 1 minus 24 by 1 plus 24. So k has been calculated. Afterward, we will going to calculate, we will going to add the surcharge at 9.81 into 7. That will be going to be the answer for this problem at that point. So we will show, you will see the solution. I have already stated the solution how we are going to solve it, but not writing over here at this time due to the some time constant as well. So you will see. See. So first of all, we know k into sigma b minus 2c root k. First of all, I calculated the sigma k value over there. That is going to be found to be 0.4217 for phi equal to 24 degree. Now, below the water table, pressure will be not multiplied with K. This is most important thing. The water pressure will be not multiplied with K. So the Q need to be removed and it will be added separately. So the sigma is 1 into gamma B plus 4 into gamma set plus 3 into gamma set. So this will not work. We have to calculate 1 into gamma B plus 4 into gamma dash plus 4 into gamma W separately plus 3 into gamma dash plus 3 into gamma W separately, and in this way we are going to calculate the value of k into sigma v minus 2c root k plus 4 gamma and plus 3 gamma w has been added separately, which I have explained during the discussions over there, and ultimately we are going to find the value as 69.65 kilonewton per meter square, and this is the answer which one is interested in asking. They are not going to ask the total earth pressure in during this case, because for that the calculation time will be little more long, but it will be asked if you are giving small examination. The question is not framed to ask the total earth pressure. But if you are giving the any examination over the written question could be asked at your university examination, or maybe at some certification examination of NPTEL only, or maybe if you are giving the engineering service mains examination or the civil services paper of the civil engineering, over there you come across this question. So 69.65 will be going to be our answer. Okay, I think so. The things is very much clear. I think so. There will be no problem. Okay. I think so. This is not needed anymore. So I'll erase this. Okay. Now you will see the next problem. Only two more problems remaining. Two or three problem remaining over here. Afterward, we will move to the seed pile wall, which is the one of the important discussion which I want to take during this session only. So, see, the consider a rigid retaining wall with partially submerged cohesionless backfill with a surcharge. Which on one of the following diagram closely represent the Rankine active earth pressure distribution against the wall. So up to this time there will be no confusion in anyone's mind to answer this problem. So you see the surcharge is there initially. So the first of all, up to a specific extent it is going to extend, and it is talking about the active earth pressure with cohesion less backfill. So no minus 2c root k is there. So the option could be either C or B, but the C is completely incorrect because it has been shown like some tension crack or whatever happened, I don't know. So the option number B is going to be the correct answer for this problem. So option number B is correct. And this explanation is very well understood by you. See, the surcharge is there. So this surcharge will ultimately result in the formation of so like you write k into gamma z plus q for z equal to 0, k into q is there, so that k into q will be formed, and afterward the k into q plus gamma z from z equal to 0 to z equal to h, the linear variation takes place. So the diagram which has been plotted in the option number B or over here is the correct answer for this problem. Okay, I think so. Everything is well and good, and understanding is properly clear. Now, see, a question asked over here: a rigid, smooth retaining wall of height 7 meter with a vertical backface retained saturated clay as backfill, and the saturated unit weight of undrained cohesion has been mentioned. Saturated unit weight is also mentioned, and the cohesion is also mentioned as 20. Now the difference in the angle of lateral forces on the wall, kilonewton per meter length of the wall in decimal places before and after the occurrence of tension crack, is that if it is asking about the before the occurrence of tension crack, the section above the above the ZC, that is 2C by root K, is not neglected, but afterward it has been neglected. So the difference will be of the 2C by gamma root K has been changed. So we will see. You see, for this problem, first of all minus 2c root k is there, then 2c by gamma root k is the zc, and 2zc 2c by gamma root k. It has been asking in the kilonewton per meter. So earlier the stress diagram has been plotted over there to the difference of the shaded region to the unshaded region is the solution of our problem. So the answer for this question is 46.7276, and this how you will understand this fact. So I will explain once. I think so it has been understood by you, but I will explain for the consideration. Like I think some people might be unaware about that fact, so I will discuss for those people. If you feel it is not needed for you, otherwise there will be no problem from my side. See, first of all, the stable meter height has been given. So we have to find the value of ZC as 2C by gamma root K. If you find 2C by gamma root K, it will be come to 2.32. And if tension cracks get developed the section above 2C by gamma root K, specifically the distance from the soil surface to the 2C by gamma root K, the stress diagram is not plotted, it is zero, and it has been started from the depth of 2C by gamma root K up to the bottom, up to the 7 meter. So the second diagram, which I mean plotted on the right hand side of the presentation, represent the stress distribution after the formation of tension crack. Similarly, if we neglect the formation of tension crack, so the negative and positive stress area, which had been shown over here in the image, first of all, if you see the this image, this negative and positive area get neglected. See, this negative and this positive area have the same area, so this negative positive get cancelled. So we calculate this much area only. Now see, if we compare this picture with that picture, I think so. The cursor is visible now. Okay, listen. Allow me to check. Afterward, I will again see whether the cursor is visible to or not. Yes, it is visible. See, so the over here, the difference in the area, the second portion of those two pictures is this one only. So if we find the area of this, we are able to, if we are able to find this area only, we are able to answer the difference. So the over here, the different consideration has been taken to calculate that area, but in my opinion, if we find 1 by 2 into 2c root k into 2c by gamma root k, the answer will be coming to be the 46.7262 kilonewton per meter square, and the difference which I asked for. Okay, I think so. There will be no confusion in anyone mind up to this. If there, anyone can ask at any point of time. Okay. Now we move to the last problem for the earth pressure theory. Specifically, not earth pressure theory, specifically for the earth pressure theory, but we can take some more problem if needed. But I think so that much will be more than sufficient. Okay. So the question is 3 meter high, a 3 meter high vertical earth retaining wall retain a dry groundwater back filled with the angle of internal friction at 30 degree and the humidity at 20 kg per meter cube. If the wall is prevented from welding, no movement, the total horizontal thrust in kilonewton per unit length of the wall is. Okay, so a 3 meter wall has been given and earth pressure at rest has been specified. So first of all, you find mu as 1 minus sine 30. After that, sorry, you find k as 1 minus sine 30, and after that you find 1 by 2 into k into gamma z square, and with that you. Okay, I think so. There is some noise over there, but okay, give me a minute. Hello, am I audible? Yes. Okay, okay, no problem. Yes, sometimes the network issue arises, so a little interruption of 1 minute takes place. It's not an issue. Okay. So what I am talking about, it is a question about the earth pressure at rest. Basically, you doesn't anyone get confused. The angle of phi has been given. They use to calculate K as 1 minus sin phi by 1 plus sin phi. But you need to understand whether the question is asking for that, whether the condition has provided the active or passive. If the active or passive condition has not been stated, will be going to be blunder if you calculated the active or passive or pressure coefficient for your calculation. See, so first of all, read the question carefully, and afterward you will go to answer the problem. But many times it has been seen that the students see the question, see the value of phi, see the value of c, they are going for the solution. They doesn't think anything. Sometimes they calculated the active earth pressure. Most student, if the passive has been asked, and if the earth pressure at rest has been asked, then also they calculate the active. So, in those cases, that is a very big thing. Basically, those mistakes result sometimes in a very bad result. So, be aware about that. So, see, first of all, we read the problem, and afterward, I will again recite that how we understand this is not the active or passive state. Okay, see, so a 3 meter high vertical earth retaining wall retains a dry granular backfill with the angle of internal friction of 30 degree and the unit weight of 20 kilonewton per meter cube. If the wall is prevented from aiding no movement, the total horizontal thrust in kilonewton per unit length on the wall is. Okay. So this question state about this condition. For the solution of this problem, we will state like this. The no movement has been given, so the no movement is the condition of the earth pressure at rest. Okay. So if the earth pressure at rest condition is there, the value of k is going to be 1 minus sin pi is 1 minus sin 30. That is going to be 1 by 2. Now we have to calculate the earth pressure per unit length. So 1 by 2 into k into gamma h square. So 1 by 2 into 1 by 2 into gamma is 20 into 3 into 3 will be the answer. So 1 by 4 into 20 into 9 is going to be our answer, and that will be 45. So you can see 1 by 2 into k naught, that is 1 by 2 into gamma into 20 into h, so 3 square. So the solution for this problem is going to be option number C, that is 45. So we can mark that. That is not necessary, but for the sake of understanding, I will try to mark. Okay. So 45 is going to be the correct answer. Okay. Okay. I think that there will be no problem. Now see. Now we will move to the next part. Okay. Now we came across with the seat pile wall. So when we are taking into account about the seat pile wall, one things need to be understood. And that understanding is very much necessary for one and all, because the seed pile is also used specifically in offshore, hmm, to prevent the failure in. So up to the earth pressure theory, what we have studied, this is basically the basic concept of the geotechnical engineering too. Up to this, we what we have read up to the earth pressure theory, this is the basic concept in understanding which we need to develop through our study. But now we have to move to some broader aspects. When we talk about broader aspects, what do we mean by that? Specifically the some different application. Now, when we read the seed pile wall, afterward we will study the seed pile wall in a cohesive soil, cohesionless soil, and different condition has been created for those cases. So we will move into that, but before that, first of all, we understand the seed pile was in geotechnical engineering, its applications,
and its implementation result in what advantages, what disadvantages, what are the problems associated with it will be taken care of. After what we will move ahead into deeper facts for these problems. Okay, so see, so before starting, we will recap what we have understood up to this time. So we have developed a understanding of the shear strength determination in different soil. When we say the shear strength determination in different soil, we have understood the shear strength for the cohesive soil and the cohesionless soil in a broader aspects, in a better understanding with a deeper knowledge. So when I talk about deeper knowledge, specifically I am talking about the understanding to find the shear strength in different soil, understanding the triaxial test in the different condition, different drainage condition, because the triaxial test itself is one of the broader aspect test in which we could control, in which we control the pore water pressure and able to find the effective stress parameter as well as the total stress parameter, whatever we feel will be required for our calculations or understanding of C and phi. So it is a very good test. Apart from the direct shear test has been taken, in direct shear test we have understood its advantages. Like we know we find the shear strength, but one of the major disadvantages we came across, that is it doesn't say that at which plane the failure is going to take place. So those aspects are there which could be said to be a problem in the geotechnical, in a geotechnical aspects of the shear stress when we are going to calculate. Okay. Now see, apart from that, what we have studied, the Vain shear test. The Vain shear test, a torque has been provided with the help of torque T by pi d square into h by 2 plus d by 6. We calculate the shear strength, and the understanding from these three tests has been developed during the first 4 to 5 classes. So, and that is one of the basic baseline of the geotechnical engineering two coursework which we are going to cross. Now, apart from that, the analysis of parameter often from this test has been understood. When we talk about the parameter, the shear strength parameter like cohesion and angle of internal friction we are talking about, and the poor water pressure importance has also been discussed over there. We have said that if the poor water pressure is there, if the poor water pressure has been calculated and the effective stress approach has been used for all the three tests, the value of the formation of the Mohr circle will become uniform for the same type of soil. But if the different test has been used and then the Mohr circle in develop, we try to develop, it will result in a certain deviation for its different value. So those aspects you need to be think of. Now the earth pressure theory and retaining wall we have came across. Now, in earth pressure theory and retaining wall, what we understood, retaining wall is a wall which try to sustain the soil behind it or try to move the soil across it in different consideration. So now we are going to develop our idea on the seed pile wall, its application, its benefits, its advantages, its disadvantages, whether its use will be logically sustained in our current situation, at which places these seed piles could be used, and how this design takes place is also one of the important consideration which we are looking forward going for this study. Now, now first of all, see the seed piles. So you see this image over there, the steel was has been used. Okay, so don't, not go in deeper into the image. We will discuss those with the coming time. First of all, we come across the definition and understand its impact. Okay, so seat pile wall basically is a vertical barrier made up of interlocking steel or concrete sheets. Specifically, over here the steel sheets has been shown, but the concrete sheets could also be there that will be heavy as well, and that are driven into the ground to provide the support for excavation or to prevent the soil from erosion. They are commonly used in the construction and civil engineering projects. We could see it in a day-to-day project specifically at different places or wherever needed. So this seed pile was become very much important. Now the seed pile walls are typically thinner, specifically it would need to be thinner to sustain the soil behind it. Then the masonry or reinforced concrete retaining wall. We have seen in the seat wall should be the seat pile wall or could be the masonry or reinforced structure. Masonry structure first time came over here in the comment, but in the previous slide we have seen that the concrete retaining wall should be there. That must be thin, but the concrete retaining wall should be there, would be there. So for those consideration, the cantilever retaining wall is there. Now, what are the output of those sheet piles retaining walls? They can construct using the materials such as steel, must use concrete or timber. So I earlier said the material of construction for any of the thing is only depend on the type of application which we want to implement with that. If we want to sustain very much load with that, the timber is well and good. Otherwise, the steel or concrete has been needed. Depending upon its durability, depending upon its need, the different type of material could be used for the construction of the different type of sheet pipe wall. Now, the steel sheet piles are the most commonly used type of sheet pile wall due to their strength and durability and versatility. Basically, you see, if we use the steel sheet pile wall, once the work has been done, if you want to remove, we can remove. It has a recycle value as well, but apart from that, the concrete or the timber sheet pile wall is used. One thing, it's so much heavy in itself, so it will create one problem. Another fact is that the most commonly used type of sheet pile wall is the steel wall only because it has also the strength in a well manner to sustain the load behind it, and it is durable. There is no doubt the durability of the steel piles is very much high as compared to any other material like and the concrete also have durability, but if we want to remove after the construction from that place, so the steel sheet piles serve the purpose, but it is somehow costly as well at some point of time as the steel is limited in the world. Okay. Now, the seed pile wall are used widely for the variety of application. Okay, we are talking about application. We also see the different uses. So, what are the applications? Over there, the seed pile walls has been used. So first of all, retaining wall, which is the seed pile wall can be used to retain the soil and prevent the landslides, especially in the area with the steep slope or unstable soil conditions. When we are studying the shear strength, we have seen the several images. Over there, we have seen that the landslides takes place, which result in the several damage. Previously, also you have seen some of the images over there across the social media platform in which the whole sections has been falling down in a very faster manner in slopy grounds during the rainy season. And it will also lead to the damage of life and property across the globe. So over there, the seed pile was somehow serve the purpose to prevent from the failure due to the landslides in those regions. Apart from that, the coffer dam. The seed pile wall are often used to create the coffer dam. You must be aware about that, which are the temporary enclosure that allow the construction to take place below the water level. So this is the temporary structure. But before that, which we have studied about the retaining wall, that is not the temporary structure. That could be the permanent structure where the seed pile wall could be constructed to reduce the chances of the erosion across that section. Okay. Now, the third is seawall and bulkhead. Seed pile wall can be used to protect the seashore. We have seen, see, you have studied if the transport over there. You have came across these terms the many times. So these seawalls or the bulkheads have been constructed because the wave of the sea during specifically during near the full moon days has been very high and it is hitting the soil. So the no erosion takes place from that place and the strength remain in the same manner which one needed to be designed during the earlier lifetimes, needed to be maintained. So over there, the sea wall and the bulkheads serve the purpose in very good manner to protect the shoreline from erosion and flooding at the both time at the same time. Now, the bridge foundations, the seat pile wall can be used to support the foundation of the bridges and the other structure that are built over water. Obviously, for the bridge foundation also, the seat pile was serve the purpose because we see the construction of the bridges or the formation of the very foundation over there, there is too much depth has been implemented. So seat pile wall sometimes serve the purpose to create and remove the water from that places for the construction, for the easy construction at that section. Now, the one of the more places where the application could take place, that is the underground structure. The seat pile wall can be used to support the excavation of the underground structure, such as the basement and parking garages. So we see at the some places during the construction, it says support the excavation because if we want to excavate to protect the workers who are working over there, there sometimes of wall need to be created if some certain unhappening takes place due to any reason. There is a wall which try to prevent the workers from getting dumped into those sections. So that become very much important and could be act as a preventive measure for the constructions workers who are working at such situation in the construction of excavation for the construction of basement or maybe parking garage. Okay. So there is no confusion over there. Now, you see, the seat pile walls are constructed by driving. Here, the symmetry diagram also has been shown. So it has been said that it is constructed by driving the prefabricated section into the ground. The sections are interlocked to form a continuous wall, and the depth to which the seat pile wall are driven depend on the soil conditions and the required load bearing capacity of the wall. So you see how this wall has been inserted into the soil from this diagram. Over there the seat pile wall has been shown and the vibro hammer also present in this image with which the wall still has been tried to be the implemented within the soil section. This is a 3D schematic diagram, so this will give more or less the better idea about the fact that how this situation actually takes place in a field. Okay, no problem. Now, the seat pile wall offer a number of advantages over the types of retaining wall, including okay. So it provides several advantages. There is no problem with certain types of things serving the purpose. The another consideration is only required. The people thinks of the another applications once they feel that it is going to be difficult for us, some more economical or some more easy implementable technique need to be developed and that will solve our problem in 1 minute apart from which takes place many days to solve. That's why we try to find the solution. Okay. So see, the seed pile offer the different advantages. So we go across one by one. First of all is strength and durability. We already said the seed pile wall have the strength and it is the long lasting edge the whether it is made of the steel or concrete. So have a very strong durable life and can be withstand the high load and harsh environment conditions. So this is one of the point. Now the flexibility seat pile wall can be constructed into the variety of shapes, sizes, making them to substitute for wide range of applications. Speed of construction seat pile wall can be constructed relatively quickly compared to the other types of retaining wall. Water tightness. The seat pile wall can be made of the watertight and making them ideal for the use in the application where the water exclusion is important. So this is the sum of the point. Now the seat pile wall are versatile and effective solution for the wide range of construction and civil engineering. It has been seen that the at some places some obstruction are there, but this seat pile walls serve the purpose to reduce the obstruction from those places in the construction activity in the civil engineering. Now we again go for introduction. Now in this introduction, we again redefine this seat pile wall, retaining wall. So the seat pile wall are the retaining wall constructed to retain the earth, water or any other material. These walls are thinner in section as compared to the masonry wall, and the seat pile wall consists of the series of seat piles driven side by side into the ground, thus forming a continuous vertical wall for the purpose of the retaining and earthwork. You have seen these things where from some slide earlier you have seen the images over there. A hammer is trying to insert the pile wall inside the soil in order to serve the purpose which for which they are implemented. Okay, so the wall are thinner in section as compared to the masonry wall. Obviously, if it is not thinner, it will become heavy. So there is another consideration of bending or maybe other things came into picture which result in the problem for those sections. Now, the sheet pile wall consists of a series of sheet piles laying side by side. Okay, I have read already this point and explained as well. The forming a continuous vertical wall for the purpose of retaining an earth bank. Okay, okay, no problem. Now, the seat pile wall are a type of retaining wall commonly used in civil engineering and the construction project. It already came into our mind. So they are designed to provide the structural support. Obviously, they are provide constructed for the structural support only and to retain the retain soil or water on one side while allowing the excavation or the development of on other side. You have seen we have came across the several aspects over there. The sheet pile wall is implemented, inserted, and at one places excavation takes place, or while on the other places construction takes place at the same point. So it will also reduce the time of the project, and in a way, it will try to reduce the construction cost of the project because the cost is directly related to time in one way or the other. Okay. Here is some other information for the seat pile wall. What are the other information? Like the construction materials. The seat pile walls are typically made of steel, but they can also be constructed from the other material like vinyl or concrete. We also have seen earlier that the wood could also be serve the purpose at some places, but it's solely depend on the amount of strength or the purpose of work is equally important while using these seat pile walls at specific location. Now, what is the installation? So these walls consist of the individual seat pile sections that are driven into the ground. We have seen this in the image as well using the specialized equipment like pile driver or the vibrating hammer. This has been also seen by me. So they are interlocked with the another one another from to form a continuous barrier for this case. Now, see, there are the various types of seat pile walls also there, like the Z type, U type, L type, and flat seat piles. So, what are these things? So, the Z type, these are the seat resembling the letter Z. That's why it has been said to be Z type, and are commonly used in the both temporary and permanent application. Could be used as a temporary application, could be used as a permanent application, depending upon the need of the people. Now the second is the U-shaped type seat pile wall. So these are often used for the applications requiring a higher sections models to resist bending moment, and the L type is the L type seat pile walls are used for the application where the anchoring or the structural support is necessary. Okay. So these things are just what has been written like the flat sheet pile wall. These are the flats and sometimes used for the copper dams or the cut-off wall. So this is the consideration over there, the different type of section over there, these things could be used. Now, see the applications. We already also read the application, but again we are taking the application and usage into our consideration. So the application, the flood control. So the seed pile was are have the application like it will reduce the it will could reduce the chances of flood or control the flood up to extent. So they can use to create the flood defenses and leads to prevent water from inundating an area. Now the marine structure. The seed piles are commonly used in the construction of the sea walls, bulkheads, and quay walls. Okay. In marine structures, this is the application. For the foundation support, they are used to support the excavation work and stabilize the surrounding soil during the construction. And this has been observed by you on the day-to-day basis because this is a basic thing which could be came across on a regular basis if you have willingness to see that. The next one is foundation support. They are used to support the excavation work and stabilize the surrounding soil during the construction. And the next one is going to be the retaining wall. The retaining wall is the seed pile wall can serve as the retaining wall to prevent the soil or the water from eroding or collapsing in a true sense. Okay, now there's some other usage of seed pile wall. So the seat pile wall, other uses like the retaining wall, act as a retaining wall. In the bridge equipments, we have seen that in the bridge equipments how it has become very much useful. For the tunnels, to support the soil during the excavation, during the tunnel construction. For the pumping station, it could also be helpful. In a water treatment plants and the basements, we have seen the basement or the construction of the car parking. Over there, the seat pile was serve the purpose. Apart from that, the underground car parking, okay, it has been written over here again. Now the port facilities. We have seen in C sections over there, the protective layer has been provided as a seat pile wall to prevent the erosion as well as the chances of flood at that section. So that is the baffle walls are one type of seat pile walls only. Now the locks and dams over there also the seat pile walls has been constructed and the pile foundation is also one of the important aspects which we came across while understanding the seed pile wall. Now, apart from that, the pile foundation construction, sometimes seed pile wall is to implement the foundation at its step whichever required, and the excavations and trenches is also another thing. Apart from that, coffer dam, we have read the coffer dam. What do you mean by it? And the groundwater diversion barrier for the groundwater treatment system, and the containment was apart from that the flood protection also it serves the purpose. We have also seen that the seed pile wall could be used in a slopy ground where the erosion could be prevented and reduce the chances of failures over there during the rainy season. And apart from that, the tunnel cut and the cover, bulkheads and the sea walls, weir walls, slope stabilizations, and in a landfill at those locations also, the seed pile wall application has been widely seen. Okay. Now, the some more advantages which we came across with the seat pile wall is like the seat pile wall was include their versatility, ease of installation, and cost effectiveness compared to the alternative retaining walls method, and the environmental consideration when we came across the choice of material and the construction method for the seat pile walls can have environmental implications. And the efforts are often made to minimize their impact on the ecosystem and the aquatic life. When you talk about the maintenance, the proper maintenance is essential to ensure the long-term stability and the effectiveness of the seed pile walls, especially in the marine environment, where the corrosion can be concerned. Now, the seed pile walls are important engineering solution for the various construction and infrastructure projects. Like and their design. The implementation depend on the specific requirement and site condition of each project as well. So it has been seen that it serves the purpose in a at different places. Like you see, we have seen its usage at many number of places. But wherever we are using this, it needs to be very much clear in our mind, like whether its application, its implementation could be in a right direction. Like it is not like that wherever not needed we provide it, because it will also result in the increasing of the cost in one way or the other. So we come across. So okay, so I will take the type of seed file wall as well. Afterward, I will sum up the session for today, and afterward I will take the next session in which we discuss some more points about the SQL was and maybe some design considerations, some problems related to same. Okay, so the type of seed files. There are mainly three type of seed files. The steel seed files are the most commonly types. We have seen steel. We have seen the different material could be used for the construction, but primarily, the three type of seed piles are there. The steel seed piles are the most common type of seed pile and are available in the variety of cross sections and shapes. The timber seed piles are the less commonly used but are still used in the some applications such as the temporary retaining wall. Third one is the reinforced concrete seed piles that also has the less commonly used than the steel seed piles but are often used in the permanent structures such as seawalls and coffer dams. So one needed to be understood the different type of seed pile was of the different materials are there, but the steel seed pile was are the most common type. Other two seed pile could also be used and have some applications where the temporary structure retaining walls could need to be constructed. But the steel seed pile walls are the most commonly used. Reinforced concrete seed piles wall very less commonly used. Why? Because it has it's heavy also and it has permanent structure, so the deformations or the type of places different consideration which we require is not fulfilled with them. So these are only used at specific locations where provided. Okay, so this has been seen. The different type of materials which could be used in the seed pile was are the wooden seed pile, precast concrete seed pile, but it has a limited application. And the steel seed pile could be used at many places or almost all places. Apart from that, aluminum seed pile also seen to be used in a present time at different locations. You see over here the various type of wood and concrete seat piles. You see that how the seat piles are joint constructed, the spines are there, cross section are there. Elevation are also presented and the reinforcement is also shown to you in the type of seat pile walls. So up to this, I will sum up the today's sessions, and from next session we will go ahead in our consideration and understand the fact about the study. So before closing the session, I will sum up the session before closing. So what we have understood from the today's session. That is one of the important aspects output from the today's session. So the output which we have obtained about the Earth pressure theory and the past what we have studied, we have discussed. We have taken the implementation that what the basic understanding we have developed during the course up to this time is taken into account. Afterward, the Rankine theory and Coulomb theory discussed in a brief. In a Rankine theory, the active earth pressure theory, passive earth pressure theory, and the earth pressure at rest. Questions has been solved today, and the seed pile was basic understanding, introduction, and the type of material could be used. Its significance, its application has been discussed. Its advantages and disadvantages will be discussed in a next class. Over there, you will come to know that how much it is useful. It, up to this time only, whatever we have read in a seed pile wall, you must have developed the idea that it is going to be the one of the most important significant structure which could be used in day to day life by the civil engineers, which will lead to the ease in construction process at the different locations. Now, the questions which guide is again the same question which I have kept during the last time, that is the Rankine theory, assumption of Rankine theory. Apart from that, add two more questions, the Coulomb theory and the assumptions from Coulomb theory. Afterward, you need to solve all the problem which has been discussed today or in the earlier class from today, and if that much question would be enough, but I will suggest that to solve some more problems from the textbooks or the reference book which has been mentioned in the introduction class of this coursework only. So that will help you to build better concepts regarding the same. Okay. Apart from that, I will suggest you might go up to from these two books also. So these two book also contain too many questions on this topic. So that will be helpful for you for the broader understanding of the knowledge. And if any doubts remain there, you can came here to me and ask me during the class time. I will happy to help you. With that, I will wind up the session for today. Thank you for attending. We will see you tomorrow. We will see you in next week, next Saturday from 3 to 5. So thank you very, very much for attending the session. So over here, I am ending the session for today. Thank you very much.